Hey all, welcome back to the lab. In this video, we're talking about why Theo, aka T3.gg, ditched serverless. And does that move make sense? So Theo recently announced in a new video that we stopped using serverless. The results are insane. And so in this video, we'll go over what Theo was building, what the serverless migration entailed, including the results, and whether serverless had anything to do with this change. All right, so what is Theo building? So Theo is building UploadThing, one of several products under Ping Labs, and the tagline is better file uploads for developers, and they're basically building a better S3. You can look at that here. Now, Theo has been famous and maybe infamous, honestly, for using and promoting serverless technologies, and so this move away from serverless seems like a new direction and follows a more widespread trend that I've been tracking here on the channel of ditching serverless for more traditional options, like a server. All right, so why did UploadThing ditch serverless? So the exact reasons of the move are not shared, but we can look at the overall goal of the product and its end results to get an idea of this. Here is the announcement post here, and I'm pulling stuff from that. And so the stated goal is basically to make UploadThing the best way to upload files, which means moving away from S3 direct uploads, S3 being Amazon's static file asset storage. And so clearly there was an architectural issue here preventing them from further evolving UploadThing, at least in the way that they wanted to. And they're saying that that's due to S3 direct uploads. And the results itself led to much faster uploads when comparing V6 to V7. So multiple images went from 4.7 seconds to 1.3 seconds, which is about 3x faster. And single images went from 3.7 to 0.7, which is about 5x faster. And so we can basically infer that the reasons were probably started off as like unlocking new capabilities, and then probably a side effect of this or a secondary goal is to be more competitive with faster uploads. Though really I would say that unlocking new capabilities is probably the biggest driver of whatever this change was. All right, so what did this migration entail going from serverless to, well, not serverless, aka server? Now the migration itself was really a re-architecture of the upload flow. And so I'm pulling the system designs that Theo had on his video out here just to give you an idea of what this looks like. And basically the old way looked like this. So we have the user browser, server, UploadThing servers, or at least service, S3, and an S3 Lambda. And basically what happens when you wanted to do an upload is user would ask for some sort of token, the server would ask UploadThing for the token, that would get returned here, and then the user would use that info to actually upload the file all the way to S3. S3 only emits completions via like AWS events, and so there's no way to have like a webhook from here, and so they tried to build a webhook, but due to S3 limitations basically had to use SNS or SQS. So this completion event would come out when the upload was finished. S3 would then call back to UploadThing so that they had their own webhook here. They would call into the customer server to tell them that the completion or the upload was completed. Presumably they would save something in their database so that they know that they have whatever they were asking for. This would return an OK to UploadThing, and then they would change something in their database so that the user here knows that everything went okay. And basically they've been polling this whole time, just waiting for, whatever is over here in UploadThing to change. So a lot of hops and a lot of services. And really the things to highlight from this is that the old architecture had about 7 individual requests, here are all in different colors, and 3 different services that I'm calling out here, which is the server, UploadThing server, and a Lambda. Now I can go on to the new architecture, which is V7, and the highlights here is that it's gone down to 3 individual requests and only 2 different services. And they do this in 2 main ways. So the first thing we can see here is that the customer server doesn't need to ask UploadThing for whatever this token is, so they just hold it. And so this is reducing 1 request. The next thing that we see is that the upload goes directly to UploadThing server, and then they proxy it up to S3. And what this allows them to do is negate all of this weird S3 webhook stuff that they were doing manually. And instead, once this is finished, they can just emit the onUpload complete webhook themselves, and within the same request, just return directly to the client. And so this architecture is much, much simpler, way less requests, and then less services that have to get called as well. And so the big things to call out is, no initial pre-sign request, which removes 1 request, and then UploadThing is acting as an upload proxy. So we remove 3 requests, we remove that Lambda, and we remove that client polling, which has been polling the whole time waiting for a response. And so technically UploadThing did remove its serverless component, this Lambda, and in doing so did get 3 to 5x improvements in end-to-end upload speed, which is pretty sweet. But is the move off serverless actually what led to these improvements. And so were these improvements attributable to the move off serverless? So really the biggest change is a lower count of requests, which incur network hops, and this amount of services involved. And so the network hops are notoriously one of the most expensive operations in a web app. And so going from 7 to 3 is a huge win. And the removed Lambda, which is the serverless function, the serverless component of the system, may have been a bottleneck itself. So serverless functions have variable latencies based on their cold starts, their priority in the infra. There's often like limits on concurrency, things like this. And then there's also some implicit operations that have to run before it's even called. So, S3, as we said, doesn't allow webhooks by itself. So what it does is it emits an event which has to go through SQS or SNS, and then this in turn has to lead to spinning up a Lambda, which is already several hops here that are just kind of implicit, which could have caused hidden bottlenecks itself, and also, variable latencies and stuff like that. Now this is total conjecture. I really don't know how much of their latency this caused because I don't have access to their data, but this is probably the biggest reason why the Lambda would have caused latencies if it was a big part of that. And so my guess is that really these were the biggest improvements to latency. Not a strict move from serverless to server, but actually getting rid of these network hops and these kind of hidden bottleneck hops from S3 to Lambda. And I think this is a bit easier to see if we simplify UploadThing's architecture. And so here we can see that what UploadThing is really doing is it just needs to be able to receive a request, act as an upload proxy, and then make a new request. And really, this should be achievable on both serverless and server architectures, whether that's a VPS, a serverless function, or serverless container. This box probably could be a Lambda serverless function. This probably is not a long-lived connection. This could also just be a serverless container, which really is just, the workload you'd run on a server just served in a container and you don't run the server itself. Or it can be a server as they chose here. And so I think the answer is yes, the removal of the serverless function likely helped with the latency because functions themselves just often aren't the most performant, but it's likely that the re-architecture itself is the bigger win that led to all of these latency improvements. Next. So I like system updates like this because it's always interesting to peek inside how people build and run their systems. Thanks to Theo for making this deep dive, and congrats on 3 to 5x improvements. That gets increasingly hard to do as your software matures. Now, I personally lean towards monolithic containers, whether they're on a server or they're on serverless, as I find them to be a simple, scalable system for running most workloads. And I think their decision to move off of serverless functions will probably work well for them long term. And I personally think that most people should ditch functions. If you're writing a function, you can probably just write an endpoint and do it better. But it always depends, and I think both server and serverless have their place and are here to stay long term. Now, if you like this post, you might also like some of these. If you're interested in cloud migrations, why Zig is migrating from AWS to self-hosted. If you're into serverless horrors, how this developer's side project racked up a $100,000 cloud bill on Netlify, and 5 ways to avoid the same fate. And if you're interested in how I like to build web apps, the HAM stack, a simple scalable tech stack for building modern web apps fast and cheap. So that's it for this video. Thanks for watching, and I'll see you in the next one.